Right, everybody. Oops. Well, thank you for coming today to the first session of the year of LDS. Today we have a very interesting presentation today on trash detection on images by our friend Mahavir, who is a grad student at UCF, and he has knowledge on computer vision in different startups in there. So Mahavir, it's all yours.
Okay, thank you, Luis, for the introduction. Hi, everyone. So about me, I'm a master's student of computer science at UCF. I'm doing research in computer vision basically, and although I do software development, but majorly my work lies in computer vision. And before coming to UCF, I was back in India. I have a couple of years of experience in computer vision and with startups which were doing basically computer vision. And this project comes about a company called Fisha. We are trying to develop a trash detection system, an AI-based trash detection system where you can use computer vision models to detect trash. So brief background about me. I've worked with institutes in India for projects like, this is a project called pest disease detection. So in India you have farmers growing sugarcane crops. So in crops you have a lot of pests coming in which destroys the whole crop. So what we did was build a basic app from where they can take images of the crops, and then based on those images the farmer would get to know if, okay, this is the particular disease in the crop, and they can take this action for that. So this is one of the work, and it has been published. The other one was with a startup. We were trying to fetch whatever details we could fetch from a single frame of image. So this was trying to fetch various details of the car, starting from what color it is. So it shows red, and then you have what kind of vehicle it is, four-wheeler, license plate, and if it is a private or public owned. So these kind of details from a single image. Then other work on which I worked on was with an insurance company. This was majorly for damage detection. So when you have an accident or any kind of situation, you would take a first picture based, rather than people clicking or going through the whole database in the company. We tried to automate it into various categories so that you can get to know, okay, this has been pushed, which categories should we put into, to what extent it is critical. So it was damage detection. You can see for scratches and then completely damaged car and a fine car. So that was about me, and a bit of overview about the talk. So I'll have some quick questions just to know about the audience. So quick raise of hands, like if you guys can tell me how many of you guys have, know about convolutional neural networks, like have, okay, awesome. And how many of you guys have trained CNN on their own custom data sets? Like, annotated something and trained it on their own stuff. Okay, cool. And then how many of you guys know about Panoptic Segmentation? Okay, cool. And awesome. So let's start. I think not many of people of you know about Panoptic Segmentation. So I'll give you a brief overview how things went about Panoptic Segmentation, what it is, and we'll see at a demo of that. So first I'll describe the problem statement, what we are discussing today. Then I'll go why we are using deep learning for that, to solve this particular problem statement. Then brief overview till the point of Panoptic Segmentation, and the libraries which you guys can go about and try to implement the same which I tell you today. And finally I'll show you a demo, and then we'll see the results on our own data set. So what is the problem statement? What we are trying to solve here is, this is a very general problem statement. I'm not claiming that I'll be able to solve it completely, but this is kind of something which gives us a motivation. So we throw our trash inside the inside a trash bin, and we should be able to detect from our model if it is recyclable or not. So this is the basic problem statement under which we'll be implementing various models. So what is a Fisha bin? So this is a company, we are trying to develop a trash bin on the extent of that. So rather than having a mechanical, so you can, you can imagine a bin where you can segregate both the recyclable and not recyclable, but we are not doing that. What we are doing is just you throw the trash and we are trying to give you points. That's it. There is no other segregation happening in the bin. So it's just a simple bin placed with a camera. So this is how it works. This is kind of the scenario which we create. We try to segregate into the quality of waste. Then we reward you based on the trash you threw in the bin. And then finally we are trying to adapt it to because we can't build our own bins. The whole idea is about building a technology which can fit into the existing bins. So that is what the aim is. And then finally, the same technology can be used at segregation centers, where you have conveyor belts, and we can fit the same camera over there and try to detect the various types of trash. So this is something how current our Fisha bin looks like. So if you can see over there, we have mentioned the steps. So we start with you have your own trash, then you put it over there to push. So there is something there is a knob there. You push it and put the trash over there, and then third you log in. So what we have done is that it would be mostly placed in offices. So rather than anyone coming and throwing into the trash bin, it would be for that particular office. We want to give the points like whoever have registered with the trash bin would be able to do it. And then you log in, and then fourth you throw your trash. Fifth, you close the whole, you say that you are done. And sixth, you check your app to see the points you have received. So this was the basic model we are doing it, and then this is the technology that we have a camera in the trash bin which will be taking the images then sent to the server, and then the response is being stored on the database, and finally you are awarded points on that. So for any machine learning model, we have to have data set. So how did we went about preparing our data set is we tried to inculcate as many as classes which we could find in our trash. So this project is being done in France. So most of the classes you'll find belong to the trash categories in France. This one is like we have plastic bottle, plastic flasks, then we have yogurts, creams, meat packaging, snack packaging, plastic bags, plastic packaging. So some of you might ask why we are segregating into so many classes of plastic. So when we have any machine learning models, they tend to learn it the way we learn things. So if you have this meat packaging, although it is in plastic category, but looks very different from this plastic bag. So rather than putting into a single category and making it hard for the model to learn, generalize on the plastic category, we try to make it learn differently, and then at the end of once the model has learned, we can do our own processing, post-processing to put it into a plastic category. Yeah, so then we have other tetra packaging, cartoon packaging, and brown paper box, cardboard glass, these kind of categories, metals, cans, metal flask, aluminium, and then paper and glass. So these are the categories. So this would be a conveyor belt, a default conveyor belt. If you go into a trash segregation center, that is how it looks, like the trash would be lying over there. So this is our first use case, and this would be the other way, where we have a trash bin. You throw the trash inside the trash bin, and this would be our top view image of camera. So if the camera is fitted up on the trash bin, it would look something like that. So we are trying to solve for these two problem statements. Our model, we are trying to build a model for these two types of problem statements. So why are we using deep learning? What was the motivation behind using deep learning based models for this kind of problem statement? One was that because if you have worked on classical image processing models, most of them you have to fine tune manually. You need to have a knowledge about what kind of information you have in your image that is something which is a very cumbersome task, and you should be expert of that area. And even then, you might miss something which is not visible to you, but that could be a pattern in the image. So that is one thing, that deep learning models automatically learn those features, so that makes your task very easy. Then this is one of the major reasons, because in, let's say we have some domain like medical imaging where we don't have that many images, so we have to see if we can apply deep learning or not there, because we don't have that many images. But in case of in trash detection centers, I think there won't be any shortage of images. So that is one good point. So, and the final thing with this is that because we want to make it as independent as we can. So NVIDIA and other companies are coming up with SoCs and boards like Raspberry Pi, which have low cost, and we can do deep learning over them. So that makes us, like, if we can incorporate and make all the bins smarter. So that was one of the use cases, and this is something a deep learning can do. Okay, so I'll before going to Panoptic segmentation, directly jumping into Panoptic segmentation, I'll like to give you guys a brief overview from where we started and to what point we have reached in computer vision. So these are various problem statements we have in computer vision, and we use different techniques to solve it. First one is called classification problem, where given an image, you would try to find what all classes are there in an image. So for, let's say this is a given image, you will have when given to a model, the model would try to output, okay, there is a board and there is a person. So there are some disadvantages for this approach is that first, you are not able to tell where the board is, so you won't have any coordinates, and then you are not able to tell how many persons are there, and then you are not able to tell if the size of the board is very big and the person is very small, you might miss the person. So that is the disadvantage with this model. So this is a basic classification model. These are majorly used in medical imaging, where you have only one tumor in a cell. So in that case, it works somehow. Because the size of the tumor would be the major part of the that image. But in case of real life, we are not usually using these kind of models. So how do we solve this problem statement? We come up with object detection models, where we are able to detect the class, the instance, and then we are able to draw a bounding box. So what does bounding box help us out in? It gives us coordinates. So if you want to locate where that particular instance is, we can use those coordinates for that. And even on top of that, you can get the count of how many persons are there in that image. So these were the major. First was a classification model, the other one was object detection model, and then we have something called semantic segmentation. So what we do here is that we try to, so an image is built on base of pixels. So there are like for an image of 250 cross 250, there would be 250 cross 250 pixels. So what we are trying to do here is that for every pixel we are trying to find a class. So here you can see there is either a background or a person. So all the persons would be given a person, all the pixels belonging to a person would be given a person class, other than there is no class. So the disadvantage you can see with this model is that you are just able to see, you are not able to count or differentiate between the person. There is a single mask for the whole person category. So that is the one disadvantage. So now coming to the next stage of models, we called it instance segmentation. So now, although we have pixels, we also have a unique identifier for all the persons. So person 1, person 2. Now you can see there is a difference in the mask of each person. So this is how instance segmentation model would look like, the output. So you have all those persons, and then you have mask for all of them. And we call this is a result of state of the art instance segmentation model called mask RCNN. where you get mask for all the people, and then you have object detection also along with that. So the whole idea is why should we go about this is some so if you have used or heard of anything called self-driving cars or in that domain, so if we give something like this, the disadvantage would be if there is a car driving over here, it would know, okay, there are people walking nearby, but it won't know the other kind of stuff, like where is the ground, where is the wall, and where is the sky. So for a car to navigate, it should have information about the whole image rather than just the pixels, just the persons. So now the next kind of model which we are looking into is that having these mask of people also, but whatever information we couldn't fit into a thing category, which we, like for example here we can count people, so that is a thing category. But if other things like for example background of pavement or a wall we can't count, they should also be reflected in the image, because that is how we'll be able to navigate. So this is the motivation for going for a other kind of model where we can have information about the whole image. So we call it Panoptic Segmentation model. So was it like, did you guys get what I'm trying to say, or how are you understanding? Cool. So shall I go ahead, or you want me to go back, or if you have any question? Yeah, sure.
So it sounds like you're saying that it's essentially an instance segmentation, but not just of the people and the baseball bats and the dog.
Yes.
So in other words, it's an instance segmentation, including the wall, the sky, the ground.
Yes, yes, perfect. So it's an instance segmentation involving. So as of now, we were doing we were majorly interested in things, so which we can count. Now we involve instance segmentation for things which we can't count, for sky, for a ground, or for a pavement or a lake. Like the parts of the images which we can't count, we want to do instance segmentation for them also. That is what the Panoptic segmentation is majorly doing. So here you can see. Does that answer your question?
Yes.
Yeah. Okay. Cool. So what you can see here, that even though we have images of people on horses, apart from the horses and people labeled, you have the forest area labeled also, and then you have the pathway also labeled. So in this image, if you try to navigate, you will be easily able to navigate because you know where is the path. But in case of instance segmentation, we won't be able to do that. So same goes for people playing games. You can see apart from the people, you have pixel-wise information for other parts of the image also. Same goes for for the people doing voting. So when we train a model or a deep learning model or any kind of machine learning model, we should be very well aware about what would be the output of our model and what should be input of the model. I mean, you should be knowing about your data set. So given if we are doing just the classification, which I started with, if you are doing classification, you would be knowing, okay, you want to classify it into cat, dog, bicycle, or nothing, something like that, and you will get output for that. You will get probabilities of an image as something like this. So if we give this image to a classification model, we'll get output of a cat being present in the image as 80%, and for a dog it's 10% probability. So this is kind of a classification model. So if we are doing for an object detection model where we were trying to find the coordinates, we should be the output would be something like this, where we have the categories for all the bounding boxes to which category it belongs to. Along with that, you have coordinates, the top coordinates, x and y position, and along with that length and height, and the prediction to which category it belongs to. And then comes the instance segmentation model. So for that, we get three things as our output. First one is your classes, to which class it belongs to, that particular instance I'm talking about. Then you have its coordinates, the bounding box coordinates, and then you get a mask of that particular instance. So this would be an output of instance segmentation model. this was the basic model which I started with, where you have pixel-wise information of everything. So it would be just a classification about the categories on which we trained upon. So because we trained upon background, payment and cat, so it would give you information, okay, if it belongs to any of those categories. Now the major model which we like to where the computer vision is progressing is called Panoptic Segmentation, which tries to inculcate all of them into one single model, where you have, you get the information of masks, and then you get the information of their coordinates also as well. So here you can see, because there are multiple cats in the image, you get the information, okay, this is the cat, and then you have an ID to which cat it is. So you have cat 0, cat 1, cat 2, and then you have background. So there are two kind of annotations in a panoptic segmentation model. You have things which are countable. So for example, you train a model on chair. So chair would be something which is countable, and a person, that is countable. But if you take an image of this place, there would be other things like this ground area, it won't be countable. So that would come into stuff. So that is how you train a panoptic segmentation model. You annotate and you give information about what are your things and what are your stuff. And this would be something an output of a panoptic segmentation model. So majorly you can think about panoptic segmentation model in something like a self-driving car. This is the place where it would be used mostly, because you want to navigate into a frame where you should know what all things are there. So now this was all, the theoretical part. Now for an engineer like me and anyone who wants to implement it, you should be able to have a knowledge about how to go about building all these things. So you should be able to, when you decide for any of the deep learning models or any of the machine learning models, what you think first is framework. So which framework you should use, PyTorch, Caffe or scikit-learn, all these, there are like plethora of frameworks around. And then you think about which models you should use. So for example, I told you guys about object detection. There are multiple object detection models, and you can use any of them. For example, there is YOLO, that is one object detection model. Then you have faster RCNN, that is one object detection model. So how do you decide which model to choose? This is one of the question. And then, for example, you are a startup, you are building something. Although you know this would work as in your research lab, but how efficient and how to what extent you can deploy into your product. That is also one reason when you go about choosing the framework. Then production level. So when I was working on license plate recognition system, we started with Keras, but when we were going about to implement it in cloud, so we realized Keras was not that production level. You were not able to optimize it for multiple GPUs. So that is one thing you have to keep in mind when going for a framework or a library. Then the same goes for scalability. For example, TensorFlow and PyTorch are very much scalable. You can build multiple models of these libraries and then combine them to build your product. So these are few things when any of deep learning companies, as a company, startup or a person, if you want to dive into a project, you should keep in mind while deciding your software stack. Okay, cool. So is it fine for you guys what I'm telling right now? Like, shall I go ahead, or you want any doubts? Cool. Okay. Thank you. So yeah. So there we come to know about Detectron. So what is Detectron? Basically, you can say Wikipedia of models. That is some reference you can get about it. So if you think about any deep learning model, this is the place to go right now, because what Facebook has done, it has inculcated all deep learning models into a single library. So it would take care of all the needs which you have from a deep learning model. It is basically for object detection, but as they research, they grow on their research, they'll include more other models into this. Yeah, so earlier they had Detectron. In 2018 they launched Detectron. Last November they launched Detectron 2, and it is far superior than Detectron. So if you might have not heard of Detectron, you are not like you didn't lose anything. That was not that great. Detectron 2 is something which is very wonderful, and the reason for that is that it is very faster, and then it is based on PyTorch library, which is one of the most frequent libraries used by deep learning people. It's accurate, so all the state-of-the-art models are included in Detectron. And then one of the major reasons for its being successful is it is modular. So you can build different models and then combine into a single model, or you can because this is a single library for all the models. You need not to worry about various frameworks or various libraries underneath that. So this is something which after the talk you can look into. We call it Model Zoo. So what it does is that there is a repository of all the deep learning tasks or all the training models which they have kept for you. So for example, if you want to do object detection, so faster RCNN is a model for object detection, and if you want to do object detection, you can just directly go on this Detectron page, and you can see which model you can use, and they have mentioned all the hyperparameters for that. So this is something, it's literally it's a zoo of models. Like you can go through it and you'll get to know what all models are there. So how do you know when to use Detectron, and is your task meant for Detectron? So if you want to find bounding box in an image, so then you are good to go for a Detectron. If you want to find a mask in an image, you are good to go for a Detectron. Even if you want to find key points or person, if you want to do pose estimation, then you can use a Detectron. If you want to do dense pose or heat maps, like for example car damage detection and all that, you can use Detectron. And if you wanted to do a pixel-wise classification called semantic segmentation, you can use Detectron. And then finally, all of this combined, what I told you, the talk is about, is Panoptic segmentation. That is the big advantage you get using Detectron. So these tasks, if you want to perform with any of the libraries, deep learning libraries, I would suggest you go first into Detectron, try to see their results, and if you want to start your bench, if you have a data set you want to benchmark, it's better to start with Detectron. Yeah, so I used for my problem statement, I used Detectron, so I'll share the results. So this is on a high, fast-moving conveyor belt. We are trying to classify, detect various kind of trash images, various kind of trash present in the image. So this is object detection. You are trying to find a bounding box around the trash. So here you can see these small stuff are yogurt packages. Then there is a plastic packaging. This is a meat packaging used in France. And then the 99.99 is the probability of being that object. So that is the percentage. So it is yogurt. The model is 99% sure that it is a yogurt. The same goes for meat packaging. It is saying it is 83% sure. Yeah. So this is one of the other results where you have on the same conveyor belt you have plastic bottles, and then you have meat packaging. So that is something called meat packaging over there, and the same way it draws a bounding box and tells you the probability of being that particular class. The same results on again on a conveyor belt, and this is the other model which I was talking about. So here we throw a trash into a trash bin and take a top image. And why are we doing this is instance segmentation. So why are we doing instance segmentation? Because if you realize, if we go about this image, so if you can see, because the objects are very far from each other, so the model is easily able to build a bounding box around it. It need not to, the accuracy won't degrade. But if you go into this image, so if you try to classify, because there is so much of overlapping between various kind of trash, so it's the model won't be that accurate in drawing the bounding box. So it's better to use a mask-based model where you have a mask for everything, and that way it learns better. So you can see you have snack packaging and meat packaging and plastic bottle. So these are the various categories in which it has classified. And even you can see a glass bottle over there. So because we trained it on the same data set, that's why it is performing this way. Okay, so this is one of the other results. You can see it's cartoon packaging, and then plastic bottle. So that is how it looks. So any questions on the results? Like if you want to discuss anything, or because after this I can show you a demo how these things happen. Yeah, sure.
Is the Detectron? Oh, sorry. Is the Detectron model already trained, or you have to train it?
So Detectron is a library.
Okay, it's just a library.
It's a library. You can say in terms of software development, it is kind of an API. So you give your model you select the model, you select, you register your dataset with the Detectron, and then you train the model on that. And you can use pre-trained models. So for example, we don't have, for training a deep learning model, we need images in lakhs. So for a normal startup or a company which is just starting up in a particular domain, we don't have those many images. So that's why we use Detectron, where they have released their models which are already trained on big data sets like ImageNet, which have a lot of categories. So that is how we use Detectron. Yeah, sure.
When you do transfer learning from the model to your application, do you retrain the backbone weights?
Yes, so that's a good question. So it depends on the, so his question was that we are using a lot of transfer learning, the models which were trained on lakhs of images to our use case. So how do we train the whole model, or do we just train the part which is, if you have trained a CNN model or any big deep learning model, there are too many layers inside a deep learning model. So if you have shortage of data set, you don't train it on the whole deep learning model. What you do is that you use models which have been already trained on bigger data set, and then you just change the last layers and you fit it according to your custom data set. So in our case, we started with, we didn't train the whole stuff, but when we have around 2,000 to 3,000 images, we just trained the final layers because we couldn't go into that. And now when we have around 20 to 30,000 images, we are trying to train it from the scratch, the whole thing. So we are trying to benchmark which results are better, and we'll use that in our production. Okay, does that answer? Okay, cool. So now I'll show you how how you can. So before that, I'll show you the.
I think there was one more
Yeah,
question.
sure.
I was just going to ask, like, it seems like the trash is going to pile up on itself.
Yes.
So is that okay? Do you take new pictures or?
Yeah, good question. So it depends. So if you see the image of our so this Pin which we are working right now, we have kind of modular structure. You see a push, and then you see a thing called open. What we have maintained is that there is a slab kept over there. When you throw a trash, it gets on that slab. You take an image, and once you're done, you pull that slab. So that way the whole trash goes down. So every time you throw a trash, it would be on a different background. The background would be same, but it won't be overlapping the old trash. So that way we are trying to achieve better accuracy. But we know that this is not which would be scalable. The normal conventional trash bins are not like this. So this is something we are working on. We are trying to do background. We are trying to do research on how do we do background subtraction in the images. Like if you throw on a existing trash, if you throw a new trash, how do we segregate the newer categories? That is what we are trying to do. Yeah.
So you said your trash basically detects what is recyclable and non-recyclable.
Yes.
So is it basically separating them?
So the business model is that we award the user the points. It won't be separating. There is no mechanical part involved.
So you're just literally throwing trash to get points?
Yes, yes. So it would be like there are two offices on this floor. One of them are using a lot of plastic packaging or maybe those things which can't be recycled, which are not good for the environment. We'll give them not we won't be give them good points, but there are people who are using a lot of paper bags. We'll give them good points. So that way you can maintain, okay, this office is good, this company is good, doing good, this company is not doing good. Because we don't want to involve a lot of mechanical stuff into a bin. This is a technology which you can put into your trash bin. It won't change your trash bin.
So, I totally understand what you're saying. So, what happens to the recycling groups? Is it still just
Separate mechanical problem
okay? Thank you.
from what I understand.
Maybe
Yes.
you can do
Yeah.
this and just put a robotic arm. You can do the inference using these models and just train the robotic arm to pick the recyclable stuff and put it into the trash.
Right, yeah.
So if you have to segregate them, you have to have a hand or something, some kind of mechanism which separates them. That is not feasible for a trash bin.
Robotic arm is too much.
Yeah.
Just blowing air and then we
So-
spin it by weight.
Yep.
Yeah.
So, I mean, what people do is generally, this would be a something trash bin, it would look like. What they ask you to do is, while throwing a trash, you don't throw the whole trash in single go. You throw a single object. So that way it would be classified if that was a recyclable or not, and then it would be it would be kept into that particular section. So if you threw a plastic bottle, there would be a bin inside that bin. There would be two kind of bin, which is recyclable or which is not recyclable. So that way you can do. So there are people have already implemented those kind of trash bins, but they are kind of where you just drop a single package at a time. So that you can do for single package. But when you throw a lot of trash at a single moment, it won't be possible. Yeah, so when you want to implement any of these image processing or computer vision problem statement, you should think about these three things. I mean, you should know if you are the one who will be annotating, because that is one of the tasks which would require a lot of effort, and you should have tools to do that. I mean, if you are, for example, if you are building a trash segregation center or you are doing something like this, there should be a person who should be able to draw those boxes, because that is what the model would be learning on. We have to teach a model using those target variables. So, and then where you will be training it. So if you have enough computation power, you can train it on your own system. But these models need to be trained on cloud if you don't have those much computation power. And then results. So what kind of results you expect from these models? So would it be an image? So if you are doing a single image-based inference, then the model can, the whole game changes. But if you are doing a video-based processing, even in that case, you need to think, okay, so you want to get that much hardware on the node. So you need to think in these three terms when you are doing, building upon a problem statement. So I'll start with so I'll first show you the videos for the various models which we used. So this was basic object detection model, how it works, that you have bounding boxes drawn around various objects. So this was a object detection model which we went through. Then so this was a mask instance segmentation model. So where it drew a mask around the person, and you have a bounding box also. So this is the second kind of model which we saw. And the third kind of model would be the Panoptic. So I'll give you a demo first on something, how easy it is to train a Detectron, because I myself didn't have a knowledge about how Detectron works. It is a black box for me. But for something like for you, if you are interested in training a deep learning model, how should you go about using Detectron? So that would be a demo of that. So first, I'll start with the tool. So there is a tool called Label Me. If you search on internet, you'll find it. I'll show you. So it's so this is one of the open source tool. If you want to, because initially you have to give your model something like this. You have to make those masks for the data set. So this is one tool which you can use, and the output or the annotation file which this model will generate is acceptable by the Detectron. So this is the software you should start with. It's called Label Me. I'll put it in the link of the video. And then once you have that, you should see something like this. So for example, I'll try to annotate one single image for you guys. So let's say we have what I'm trying to do demo is that I'll make a video of myself, and because this model is already, the existing models are already trained on a lot of categories as you saw. So but it is not trained on particular classes. So for example, it is not trained on this particular pass. So once I train it on my data set, it would be able to detect a pass also. That is what the demo would be. So currently the output of Panoptic segmentation looks something like this. So when I came in over here, this is the video I recorded. This is a general video while coming in the walk when I was walking inside. And if we go for a Panoptic segmentation model, it should put something like, oh sorry, not this one. Yeah, so this is how a Panoptic segmentation model output would look like. So you can see here it's like, I didn't make this table, but you can see most of the things they assign every pixel a class. So you can move inside. Okay. So it is even assigning pixels for wall, which is not a thing, you can't count a wall. And it is assigning pixels and the information for person and ceiling. So that is how Panoptic segmentation model works. So I'll show you how to do it. So first I'll do it for the pass images. I tried to download a lot of conference pass images from the internet for this demo. So I'll show you the data set. So this is how it looks like. So if you can see, just give me a second. So if you can see, there is a mask I have drawn on the passes. So if you go about seeing the different images, that is how you make a mask on passes. Like there is a tool, you can just create a polygon, and like this way you can keep on connecting and you'll get a mask of those images. So this is very important when you're doing any of the computer vision task or any of something. If you are trying to build up for yourself, you should know this thing, because you won't find a lot of resources on these things, because it's kind of something which because there are a lot of images available on the internet, a lot of data set available on the internet, which you can just try to learn. If you're trying to learn computer vision, you can use that. But when you're trying to build a product or trying to solve a problem statement on yourself, you should know how to build upon your own data set. So the Label Me is the software, and this is how you do the instance annotations. You can see how I've done. I've done the, yeah, sure.
And you launched that software from was that a Python window or this other window we saw open?
I mean, if you want to know how you can install it, we want to see how you can, like, for Ubuntu, so I'm right now using Linux. So,
okay.
So on Linux, I'm using command line, and I used.
That answers my question.
Okay.
Thank you.
So I used command line to launch it. But they have on their website, they have installation for, I think, most of the systems. Yeah. So for Windows also it is there. For Mac OS, and like if you are using Docker, you can still use it. Yeah. So cool. So that was demo for. So I mean, I'll show you more images. Yeah. This is how you annotate. So in that image, there is only one person wearing pass. So that is how you annotate for a pass. So I'll now go to the Jupyter notebook, which will use the Detectron library. So I'll start from the beginning. So yeah, initially I just import these three libraries. OpenCV is a very basic library for image processing, and then I import Detectron. So it is that as simple as that. You just import these three libraries to build a deep learning model, and after that you have to register your dataset. So what happens is that there are standard formats of dataset available on the internet. One of them is COCO. So what COCO is based on is it is something like this. If you go on COCO website, they have standard annotations for everything, and you have a lot of competitions happening on this. So what Detectron and the Facebook has done is that they have made people to use COCO object detection annotations. So how does it look? I'll show you one simple file. So once you annotate, you will get something like this as an output JSON file. So it would contain all the information about your image once you annotate. And this you have to make sure that it is similar to the COCO dataset which is available on the internet. So it would be something like this. You can use it. And now, so that is what I did. I annotated all of them, and then I gave this as a path, the JSON. And then I gave the path to my images. So this is the folder containing, the second folder contains all the images, and the first folder contains the JSON file, which I will be using. So these are the two things which you give while training your model. I'll run this.
So the JSON file essentially has metadata for each of the images.
Yes, yes.
Okay.
So when you do the labeling using LabelMe, it would generate a JSON file for every image. Then there is on the LabelMe, their own website, they have given how to convert those all JSON file into, for example, if you go to their example section, we are trying to do instance segmentation over here. So they have given example how to convert all those files into, so for example, we are doing COCO. So they have given you description how to do it for COCO format.
Thank you.
So this is, you need to use all your JSON files, and you need to put it into a single JSON file, which is being used by Detectron. So you go on LabelMe website and you can do that. So it is very simple. Like I tried it and I didn't get any error while doing it. So you need not to even go to the issues section of the GitHub repository. It's that simple. So I do that. Now after that, I'm converting it to metadata for Detectron. This is like a simple step for that. And then you can see what it takes as a metadata. It takes the JSON file where it is located, the path, and then the data set has been registered. So I registered it as past data set. Earlier they have their own data set, so I registered it as past data set, and then you get the JSON file. So this is something they get now your data set is registered. This is the verification for that. Now I'll visualize. So I annotated some of the images. Now you want to see, this is just a verification step. Just want to see my data set is like Detectron understands my data set, what I'm trying to do. So this is a step for that. So you guys, once I execute, you guys need to figure out the masks. Don't go for the bounding boxes. So here you can see. So now this Detectron library is trying to visualize my inputs. You can see these are the masks I built. So it is trying to figure out where the mask is. So we are good to go. We can now train our data set. And this is as simple as that. You can see. So in basic deep learning models, we have an architecture and we have weights. Architecture is, the underlying mathematics, how one image when given to a system, how it would come out as a scalar output. So that is the architecture of your model. And then you have, because as I told you, these models require a lot of images to be already trained on. If you want to get good results, like if you want to do transfer learning, you should have some weight file. So that is the other file which I'll be using. Apart from that, I'm using past data set which I created. This is number of workers signify my number of GPUs, and here I'm using 500 iterations. I'll be training it for 500 iterations, and the batch size will be 128. So I'll go ahead. So any doubts till this section? Like, yeah, sure.
So there's two ways you can do it, right? One is like you train the backbone, freeze the weights, train the regional proposal network, freeze the weights, and then train the mask head, and then that's, or you can just train them all in one go, right? Which one is this? Are you just going all in one go? And if so, what's the cost function for that?
So in this one, we changed only the final layers.
Okay.
I mean, when you give, if you see where I've given.
Yeah.
Number of. Yeah. So here you can see number of classes.
Oh, okay.
So this would be the final layer, and apart from that, I'm not changing anything. So I'll just changing the final layer. So
for your use case, did you try like both approaches, where you like train this part, freeze the weight, train the next, freeze the weight, or just like did you just like?
So are you asking for this demo?
For the garbage.
For the garbage, I did try both of them.
And did you get any significant?
So transfer learning, because we haven't touched that mark where we have a lot of images.
Yeah.
So still we are getting good results from the transfer learning. Freezing the initial weights and just training the last weights.
Okay.
Yeah. So we are still getting better results from that rather than whole training. Yeah. So in this section we just define our architecture for the model. So because we have only one class that is this pass which I have trained upon, which I have created the data set. That is the only class which I will be training upon. So I have given only one as the output class, and I'll just go ahead and train. So it would start executing here. Here you can see it outputs your model something like this. So this is something which Detectron is doing on its own end. You need not to go at any extent to understand all of this. If you're just a developer and trying to build a deep learning or a computer vision use case, you just need to look into this code and put in all the hyperparameters. So for example, learning rate is one of the hyperparameters which you can tinker around with, and then number of iterations. So how to what extent you want to train your deep learning model, that is one other hyperparameter you want to change, and then the batch size. I think these three parameters would be enough for you to check what is the best configuration for your model. So it starts training. Yeah. So this way it is training, and it gives you various kinds of losses. So you can even visualize it and use, like there are libraries like TensorBoard where you can visualize it. So it would take some time, and then once I'm done with the training, I'll save it. So it's very important to save your models for benchmarking, and if you want to use it later, because if you don't save it, it would be available in the Jupyter notebook, but once you go out of this environment, you need to train it again and again. So this is the part where you save it, and we'll visualize the results, and then finally we'll do the inference. So let's see how much to what is doing.
In the training, I
Yeah,
see
sure.
you didn't define like a test set. Is it cross-validating?
Yes, yes. So it is by default. So if you don't you don't define a validation set, it would take by itself the Detectron would take a validation set. So that is something which we can, like, if you want to benchmark your results, or if you want to do if you have a very good big data set, you can divide it into that. But I just had 200 images for this demo, so I used the whole range. So there is, if I go, so I'll show you. So this is the official repository of Detectron. I'll show you. So if you go down, yeah, so you can use something like this, TensorBoard, to visualize how good your model is doing. So I haven't used it because my dataset was very less, and there is no need to do it as of now. And you can do this, and then you can even use. These are the where we find how accurate our model is. So these are some matrices. So average precision is like finding out how good your model is doing on one of the ways. Like, it is one of the methods how we do for object detection models. So this is all available in Detectron library. You can use it. So going back into what I was training, I think should be done. So yeah, so here you can see the total training time, and click the training is done. Now I'll just save it. So this would save the model, and then I'll visualize the results. So this is, it would take, as you mentioned, right now it is taking the results from the section where it already trained upon. So that I don't have a different data set maintained for that. So I'll just show you the results. So you can see there is a small mask coming up. That is because these were the images I annotated upon, and it missed one of this mask. Let's see. So you can see starting, the model is trying to learn where the pass is. That is what we were training upon. So it missed on this. Let's see on some more images. So you can do one thing, is that there is a threshold. So this threshold tells you to show mask at what level of confidence. So right now I'm telling, if the model is 80% confident, then only show me the mask. So I'll try to get it down and see what the results are. So I'll put it 60%. If the model is 60% sure, then also it can show me the result. So I'll visualize it. So you can see the model now improves the performance. Because I asked it to show the results for even 60% level of surety. So you can see, but then because the data set is less, even you will get masks at parts where there was no part. But most generalized, you can see generally it is working good for 200 images. This is the accuracy you don't get for 200 images. Why we are getting it? Because we are just training it for a single class. That is one of the major reasons you should always think in mind while designing a deep learning model, how many classes you are training it upon. Because as you increase the number of classes, the accuracy would go down. And now I'll show. So I made a video of myself when when I came, and it was something like this. So it was I'm trying to wear a pass. So right now this is the input video. I'll play it again, and now the model has trained, and I'll show you the output which it has saved. So this is just now coming in. So you can see it is trying to fetch that. Earlier there was no mask. Now because I have trained, it is able to recognize the pass. So this way, this is one of the applications I'm trying to show. Like when people are entering in the conference, you can try to get to know who all are wearing passes, or you can even count how many have registered for the conference. So this is one of the applications of deep learning in the computer vision which I'm trying to show. Yeah, that's it. That was the. Yeah, questions? Any questions? Did you get, like, I tried to be more, clear to the audience. I didn't go into details of how this model works, but I tried to try to make it so that once you guys go home, or even if you sometimes, or in a hackathon you are there, and you try to build something in computer vision or deep learning, you want to use some library, you can think, okay, that guy told me about Detectron, let me search on it and build something on it. So that was the main motive. Sure.
On your, I noticed all your training images, of course, were like the frames, and then at the end, or sometimes along, you showed us classification on the video. So is there any difference, or it's once the model's built, it's just a matter of, kind of just doing it frame by frame on the video?
Yeah, you got it. So it's basically an image, a video is built upon frames, your combination of frames. So we just took a frame and then did the inference, and again stacked all of the frames again. So this is what is happening. It is not a video, there is no time series involved or anything such as where we have understanding of the background, the older frame. We don't have that. We are just doing frame by frame. Yes.
So when you're registering those images, are they getting imported into like Google's database, or is it internal to your own? I guess the question is, like, if I want to use this for my own company, they may not want sensitive information just going to Facebook or Google.
Yeah, sure. So perfectly. I think question was, so right now I'm using a Google Cloud. So that way it is going to in Google's hand. But if you are using your own cloud and you install Detectron over there is no way Google can get to know what you are using, because that is not an API which is connected to Google database. It's you install, so there is a procedure to install Detectron. Once you install it, you can do everything on your local system. So okay, you can even set it on your PC, but it has to be good with the hardware. Yes. Does that answer?
Yeah, that's perfect.
Okay.
Do you have any plans to use this together with mechanical systems or any other systems for sorting trash?
I think so. I'm one of the contributors in the companies in the Detect. So I think we don't have plans to do that, because that is something which a bigger scale company can do, because that is changing the whole industry of trash. How the trash segregation happens. What we are trying to do is build a technology which can help them in doing trash segregation. So that is the plan.
I think you should pitch that idea to a bigger company. But your question was just a really good question. You would want to do this so that it can help out with the robotics and the entire mechanics for everything that you might need, and then the entire crash.
Yes.
And then
We can build a prototype, but building the whole machine, I think, would take a lot. You need to have a tie up with all the partners who are doing that stuff. So I'm not the guy who is involved in the how the company would go about in various products. I'm more into computer vision, and I'm a contributor for that. So I don't have that much information how they are planning to do that.
Well, yeah, but the thing is that it's like training ensemble models, right? So if you combine this with something else, which doesn't need to be computer vision, but some other ways to separate trash, you might get better separation.
Yes.
But no, I understand. You try to solve it as a separate product from computer vision.
Yeah. So what we are trying to build is, we can think of it as a trash detection API. So where you could give your image, will give you what trash is there. That kind of approach we are trying to go
Trash
over.
as a service.
Yes.
So they already, Facebook does it.
Yeah.
You mentioned that you're only essentially training on that last layer is changing in the convolutional neural network. So I'm wondering, and I think you said the one class. So essentially now you've given up the ability to identify all those other things, right? That the model
Yes,
could
yes.
identify
That
in order to
would-
focus
yes,
the
yes, yes. That would happen. Yeah, there is no way you can. I mean, you can use ensemble of models where the image passes through both of the models, where one is built for that particular class, and even it passes through the other class, other model also, and then you can, in the image, you can show, okay, this is the direction. So you can just load two models, do the inference both on both of them, and then give a single output. That is how people use it for, like, if their basic model is very light, they can use it with the bigger model.
I noticed. I was just going to ask. I don't know if you were here earlier, but I was mentioning that there's a Kaggle contest right now. For finding fake videos.
Yes.
And
yes.
I noticed everyone who's posting on that, they're all using Python. So is R sort of way behind in image detection? R, the statistical environment?
No. R is using also the C++ libraries for Keras.
Okay.
And Keras is implemented originally in Python. So in a sense, when you're saying Python, they're all using C++ ultimately. Python is the glue language which does the, goes to
I would say it's more about, like, to what extent you want to contribute. I mean, if in that competition you are going with the motive of winning that competition, so it's better to use the resources which are up to date. I mean, like, you are doing the least effort and getting the most buck out of it. So that way, I would say Detectron is the go-to library. But when you are trying to develop your own product, something like that, so it's better to go into something which you have much more understanding of.
So to answer, like, for example, look at the competitors of Google. Say Amazon, right? Amazon, they have they sponsor MXNet, which is the alternative of TensorFlow. Or trash is happening. It was happening mostly in China. You can use the Baidu, whatever, Paddle, or the Baidu image classification deep learning library. So it's kind of, it's not necessary. They're all interfacing to whatever languages you want, like Java, Python, whatever. But most of the time they're written in C++ or C because to utilize the hardware in the most efficient utilization.
Thank you.
Any more questions? Okay, awesome. Thank you guys. And after this, I'm looking for summer internships in this summer over here in Orlando. So if you guys have any leads or anything, you can just maybe send Luis or maybe on me on my meetup, or I'll post it on the meetup link. Thank you.
Well, thank you everybody for coming in. We're going to go to the Irish pub in the corner, the Kelton, the Harp. So you're welcome to join us there.